All right, in this video, we're going to look at scientific notation, which is basically when you see a number written in this format like this. And so this is used for either very large numbers or very small numbers. So what this means, 5.13 times 10 to the fourth, effectively means 5.13 times 10 four times. That's what 10 to the fourth means. So effectively, this is just going to move the decimal point. If the number is positive, it's going to move the decimal point to the right. So if we take 5.13 and we just move the decimal point 4 spots, 1, 2, 3, 4, that is our new number. That's what this means. So this number is 51,300, which is what you get when you do 5.13 times 10 four times. If you see a negative exponent, it means take this number and don't multiply by 10, but multiply by 1 over 10. That's what a negative exponent means, and do that 5 times. So that will have the effect of moving the decimal point to the left. It doesn't make the number negative. It just makes it smaller. So there's 6.2. I move it 1 spot, 2, 3, 4, 5, and then I put the zeros in here. Notice it moves 5 spots to the left, but it only has 4 zeros in front of where it was, because the first movement was just to get to the other side of the 6. So this is this number here. And so here again, times 10 to the negative 6, so I have 8.210. I move it 6 spots to the left, 1, 2, 3, 4, 5, 6. That's going to give me 5 zeros out front. Then 8, 2. And if I want to be technical, I should keep this 0 on the end. It's not going to matter to our class, but this is what's technically a significant digit. It means that you're more certain of the number. So don't worry too much about that. But basically, if the exponent's negative, move it left. If the exponent's positive, move it right. That's really all there is to get it into regular form. When you write in scientific notation, the rule is you're not allowed to have, so you read the number from left to right, find the first digit that's not a 0. This is a 1. So I'd write 1.34, and I'm going to leave off all those other zeros. And I say, okay, 1.34 times 10 to the what? I just say, okay, if I have 1.34, how many spots do I have to move it to get this number up here? So 2 spots gets me to where the end of the 4 is, and I can see I have 3 more to get those zeros, so it's 1.34 times 10 to the 5th. We can then double check our answer by taking 1.34, moving it 1, 2, 3, 4, 5, and seeing if we get what we are expecting. And we are, so that means this is correct. So here, I'm going to read the number from left to right, find the first number that's not a 0, it's a 3, and then I'm going to immediately put the decimal point. You're not allowed to have more than one number to the left of the decimal point. So this is 3.4 times 10, and I say, okay, if I have my decimal point here, how many spots to the left do I have to move it to get the original number? It's going to be 1, 2, 3, 4, so times 10 to the negative 4. And again, I can double check that. I can go 3.4, 1, 2, 3, 4, and hey, it's what I expected. Always just do a quick double check. Here, what's the first non-zero number reading left to right? It's 1, so I'm going to write 1.01, and I'm going to keep this 0 on here because it was placed here for a reason in the original number. Here, the zeros were required to understand the number. Here, it was an extra number. It isn't going to be super crucial, but just be aware of that. So then what's it going to be? Times 10 to the, if it was here, I'm going to move 1, 2, 3 to the left, so it'll be to the negative 3. So again, don't worry about the scientific note, the significant digit too much. That's a little bit more advanced. But again, if I take my original number, 1.010, go 1, 2, 3 spots to the left, hey, that was the original number. It checks out. So anyway, that's how you write in scientific notation. Now let's look at how we can analyze some numbers, see which are bigger. So the big thing in determine whether a number is large or not is the exponent is the most important thing. So these numbers out front matter, but they don't matter as much as the exponents. So you look for the biggest exponent, in which case 10 to the 6th. So it's really between A or C, which is larger. So A is 1.89 times 10 to the 6th. It means move this over 6 spots. And so if you do that, you're going to get about 1,890,000. 2.1, move it over 6 spots, you're going to get 2,100,000. So C is the biggest. So basically, look at the exponent. The bigger the exponent, the bigger the number. And if they're the equal, the second thing you look at is this number up front. So C is the largest. Here, which one's the largest? Look for the largest exponent. So negative 2 is the largest exponent. There's none other that are bigger. A must be the biggest because, again, 4.32 times 10 to the negative 2 is basically this number. It's been moved over 2 spots. 8.01 times 10 to the negative 3, if we actually write it out, looks like this. This is a smaller number, than this up here. So the exponent's the most important. So just keep that in mind as you look at numbers in scientific notation. So anyway, until next time, I am Derek Genova. Have a delightful day.